Hi guys, welcome to your Everyday Math lesson for today. We are going to be working on Everyday Math lesson 5.11. So when we're working on this lesson today, a lot of it has to do with using equivalent fractions. So we've practiced this and practiced this and practiced this. We know how to make equivalent fractions. So we're going to work through this a little by little, and it's going to be a little bit more independent than I normally would. I want to ask you a few questions. I want you to do some things on your own, and I want you to be able to try to answer them without me having to give you the answers. So beware, there's a lot of questions probably in this video. Fair warning. All right, so for our lesson today, we're going to start in our math workbook. We're going to be on page 184 in your Everyday Math Volume 2 journal, page 184. So we are going to start by thinking about when you multiply by a fraction. So before I do anything else, this is up here, and I want you to think about something, okay? So if I multiply something by a fraction, if I have one whole pizza and I multiply it by a fraction, my answer is going to become what? Larger or smaller? What happens when you multiply a whole number or any number by a fraction? Anytime you multiply a number by a fraction, your answer is going to get smaller. If you multiply something by 1, it stays the same. So if you multiply by something larger than 1, your answer will be larger. If you multiply by something smaller than 1, your answer will be smaller. So a fraction, most of them are smaller than 1. Sometimes you might get an improper fraction. You might get an improper fraction like 86 over 85. If I multiply by that, my answer will be slightly bigger because this answer is slightly a little bit bigger than 1. So that's one of the things that we're going to practice today. We're going to practice thinking about numbers. If you multiply by a whole number, it's going to get larger. If you're going to multiply by a fraction, it will get smaller. So keep that in mind. Here we go. On number 1, it says I'm going to do 5 times 1/2 or 5 by itself. I'm multiplying by a fraction, which means that my answer is going to get smaller. 5 times 1 stays the same, right? And this is smaller than 1, so my answer would be smaller. All right, let's do by 5b. 5 times 2 1/3 or 5. Think about that one. Am I multiplying by a number that is larger than 1 or smaller than 1? So will my answer be larger or smaller? My answer for this one will be larger than 5. 2 1/3 is bigger than 1, which means my answer is going to be bigger. Think about C. 5 times 5/4. Don't let this one trick you. Is 5/4 larger than 1 or smaller than 1? Is my answer going to be bigger than 5 or smaller than 5? What do you think? For this question, your answer should be larger than 5. 5/4 says bigger than 1, which means my answer is going to be a little bit bigger than 5. All right, let's look at this next one. 86 over 87. Is that larger than 1 or smaller than 1? That's smaller than 1. I know that 87 over 87 would be a whole, so this is a little bit smaller. That means my answer is going to be a little tiny bit smaller than 5. And finally, 5 times 1. What do you think? Greater than, less than, or equal to? Easiest question of the day. This one is equal. 5 times 1 is the same thing as a 5. It's the same thing as itself. All right. So what we're going to do now is we're going to write 3 fractions that are equivalent to 1. Okay, so we learned, and we've learned this in the past, we've talked about this a few times in our lessons. We know that anything, a fraction where the numerator and denominator are the same, that equals 1. So 2 over 2. That means that if I have if I have a pizza or a cookie, if I cut it in half and I eat 2 halves, that means I ate the whole cookie. Okay? So anytime your numerator and your denominator are the same number, then that means your fraction is equal to 1. So 9 over 9. 12 over 12. 1,962,848 over 1,962,848. That's still equal to 1. As long as your numerator and your denominator match, then your answer is going to equal to 1. Now, do I want you to use the 1,900,000 whatever? Do I want you to use that on a problem? No. I was just very much trying to show you that it doesn't matter how big the number is. As long as your numerator and denominator are the same, then your fraction is equal to 1. I want you to put that in your own words. All right, so now we are going to write 3 fractions that are equivalent to 1. So I'm going to keep it kind of easy. I use the smallest ones possible. 2 over 2, 3 over 3, maybe 5 over 5. You can use 10 over 10. I try to keep it kind of simple. All right. It says use the fractions you wrote in part A to write 3 fractions equivalent to 4/5. Well, it kind of gives us one, but we're still going to do the other ones just to make sure. So 4/5 times 2 halves. Okay. 4/5 times 2 halves. 4 times 2 is 8. 5 times 2 is 10. 8/10. 12/15, it already gives it to us. Let's do the next one, 5 over 5. So 4/5 times 5/5. What is my equivalent fraction for 4/5 times 5/5? For this answer, 4 times 5 is 20. 5 times 5 is 25. 20 over 25. It says, explain how you know that your fractions that you found in part B are equivalent to 4/5. The way I would do this is I would start by thinking about what happens when I multiply a number by 1. When I multiply any number by 1, it doesn't matter what it is, it stays the same. It's the identity property. It keeps it itself. So I'm going to use that to help me. All right. So explain how you know that they're equivalent. I know that 2 over 2 is equal to 1. I know that 1 times any number equals itself. So 2 over 2 times 4 over 5 equals 8 over 10. And 8 over 10 is equal to 4/5. That's what I would do. Something along those lines. I talked about things that were equivalent. I talked about any number times 1. I talked about fractions that equal 1. I talked about all of those different things, right? That is the wording that I would use for this. Number 12. Look at the fractions in the table below. They can all be written as equivalent fractions with a denominator of 12. What would you multiply each fraction by to make it 12ths? Write the fraction name for one that you see in each case. Then find the equivalent fraction with a denominator of 12. One row has been completed for you. So basically, we're finding common denominators, guys. Basically, we've been doing this for 3 days, 4, 5, 6 days. 3 times what? All right, so I'm sorry. My phone rang and I got distracted. Ignore me. I'm so sorry. What number do I multiply by denominator by in order to make the answer and make it into 12? Well, I know that 4 times 3 equals 12, and I know that whatever you do to the bottom, you do to the top. Do you understand why we do that now? Because we're multiplied by 3/3. All right, 3 times 3 is 9, 4 times 3 is 12. I want you to find my fraction name that I will use for the next one, 5/6. What fraction that's equal to 1 will I multiply 5/6 by in order to make my denominator 12? All right, for this one, I'm going to multiply it by 2/2, and I know that because 6 times 2 equals 12. So 5 times 2 is 10, 6 times 2 is 12. Awesome. And finally, 1/2. What I want you to do right now is I want you to find my equivalent fraction. What is my equivalent fraction with the decimal, with the denominator to make it a 12? All right, for this question, I'm going to multiply by 6/6, and my answer will end up being 6/12. Awesome. And finally, it says number 4, it says pick one fraction name for one that you could use in problem 3. How did you know the fraction is equivalent to 1? I want you to write this out. Here's a big hint. Look at the words that I chose here. Look at the numbers that we chose here. Just change the numbers and you should be fine. I want you to type it out. This is worth, I'm going to make this specific part in this lesson worth 5 points towards your grade. I need math terms. I need good reasoning and good answers. Be sure to use complete sentences. All right. Choose one name for problem 1 that you used in problem 3, and how do you know the fraction is equivalent to 1? Have a great day, guys.